Hello. Um, so I thought I'd make a video to kind of demonstrate how to do problems like these. Okay, looks like I need to fix my tablet here. Alrighty. So let's get the controls over here too. All right. Okay. So now it's telling you that sine theta is less than zero and tangent theta is less than zero. And they want you to choose which quadrant. And I'm going to kind of make this a little bit less painful to figure out by just showing you a neat way to sort of think about these. So the unit circle is a circle of radius 1 centered at the origin. So the length of this would be 1. And then each point on the circle, okay, corresponds to an angle, or I'm sorry, the trig function of an angle. So let's call this angle theta. Okay. One over here. And you can always kind of just stick in a right triangle all the way around the circle. All right. So uh, in this way, setting up the unit circle, x is going to correspond to cosine of theta, and y is going to correspond to sine of theta. Okay, so let that sink in for a second. So x is cosine theta, y is sine theta. All right. So now we can map what we understand about x and y to cosine and sine. Okay, so let's label the quadrant. So this is quadrant 1. This is quadrant 2. Promise this is the only place you're going to see Roman numerals in this math class. All right, pen. Okay, my pen's not writing. Let's try that again. Okay. There we go. So quadrant 1, 2, 3, and 4, we go around counterclockwise. So now in quadrant 1, x and xy value in quadrant 1 is, so any point in quadrant 1 is going to be a plus and a plus, right? They're both positive. When we get over to quadrant 2, x is negative, y is still positive. Quadrant 3, both x and y are negative. And then in quadrant 4, x is positive, and y is negative. Okay. So now, what does that mean? That means that in quadrant 1, cosine and sine are both positive. In quadrant 2, cosine is negative and sine is positive. In quadrant 3, cosine is negative, sine is negative. And in quadrant 4, cosine is positive and sine is negative. Okay. So just kind of add this idea to your memory palace or wherever. And now I'm going to introduce one more thing that will kind of help put all this together so we can do any kind of problem that they throw at us that looks like this. So all of your other trig functions can be written in terms of sine and cosine, or this x and this y. So tangent theta is sine theta over cosine theta, if my pen will work. Cosecant theta is 1 over sine theta. Secant theta is 1 over cosine theta. And then cotangent theta. Now you could think of this as 1 over tangent, or you could think of this as cosine theta over sine theta. And for the purpose of this trick, it helps to think of it like that, because you can just go right back to thinking about it in terms of the x and y. All right. So now that's kind of the background info that you need going into a problem like this. Okay. So now if they're telling me that sine theta is negative and tangent theta is negative, well, let's put in an xy plane here. So now if we go back to kind of our guide here, we can see that sine is going to be negative. So that's the y value here. So I see a plus in the first quadrant, plus in the second quadrant, and I see a minus in the third and a minus in the fourth. Okay, so we're looking at the bottom two. So I've eliminated 2 quadrants. Now, when it comes to tangent, so tangent being negative, so tangent is sine over cosine, right? So if I have in the first quadrant a positive divided by a positive, I get a positive. The second quadrant, I have positive divided by a negative, so that gives me a negative. So tangent is negative in the second quadrant. When I get to the third quadrant, I have a negative divided by a negative, that gives me a positive. And then in the fourth quadrant, I have a negative divided by a positive. So a negative divided by a positive is negative. So tangent is also negative in the fourth quadrant. Okay. And I see that I have shaded twice in the fourth quadrant. So that is where the angle lies. All right. I hope that clarifies things for that one. Okay. And then this next one, find the exact value of the expression. Do not use a calculator. So determine the reference angle or coterminal angle for 240 degrees. So you have to draw a picture, or at least a picture will help. Unless you can picture this all in your head. Okay, so this is 90 degrees. I guess I can also mention that's 0. This is 180 degrees. This is 270 degrees. And you can say I'm just counting by 90s, and then when I loop around and meet the 0 degrees again, that's also 360 degrees. Okay, so then where is 240 going to lie? It's going to lie somewhere between 180 and 270. Okay. Okay. So now when we're talking about a reference angle, what we mean is whatever the smallest angle can be made with this line with the x-axis. Okay, so this is the reference angle. All right. So then again, this is 240 degrees. So then to figure out what this is, we're going to take 240 degrees minus 180. You know, my pen will work. Okay, so I get 60 degrees. Okay. So that's my reference angle. And what we'll find when we go to figure out a problem like this, so this cosine of 240 degrees, I don't know why my pen keeps stopping there. So this cosine of 240 degrees, what we can do with this reference angle is we can write the cosine of 240 degrees in terms of cosine of 60 degrees. Now, can we just leave it at that? And the reason I'm asking is, yeah, no, we can't. Sorry. So now we have to go back to that thinking about cosine theta as x and sine theta as y, right? Okay. So remember, this was plus plus minus minus. I'm sorry, minus plus minus minus and plus minus. And the way I remember those is I just think about the x and y correspondence. Okay, so then we can see in the third quadrant here, so cosine should be negative. So then we tack a negative sign on the front of that. Okay. Okay, and I kind of got ahead of myself. So we got the reference angle. And then the exact value, so if you don't have cosine of 60 degrees memorized yet, uh, there's a scheme for the unit circle. I'll probably save that for another video, but I'll get it from the 30, 60, 90 triangle. Okay. So all right triangles, I like to think that all right triangles live in quadrant 1. Okay, so let's see. So 30 degrees, 60 degrees, and then of course we have the right angle, 90 degrees. And then there's a special relationship between the sides. So let's see, what do I want to call this? So if I say this is A, then so the side opposite the 30 degrees, if I say that's A, then the hypotenuse is 2 times A. And then the side opposite the 60 degrees, uh, you don't have to memorize because you can use the Pythagorean theorem. So I'll just call that B for now. So A squared plus B squared is equal to 2A squared. So I have A squared plus B squared is equal to 4A squared. Subtract A squared from each side, and I get B squared is equal to 3A squared. Take the square root of both sides, and then I have the square root of 3 times A, right? Since the square root of A squared is A. And since they're all lengths should be positive, so I don't have to worry about a negative root, if you were wondering. All right. So now, so this is just a generic 30, 60, 90 triangle. The good thing about triangles is that when you do the side ratios for any triangle, no matter what its size, the ratios still work out the same. Foundational aspect of trigonometry. So now when I want to do cosine of 60 degrees, so cosine is adjacent over hypotenuse. So the adjacent side to the 60 degrees is A, and then the hypotenuse is 2A. So the A's cancel out and I get 1/2. All right, so go back up here, and then I get cosine of 240 degrees is negative 1/2. Okay. All right. I hope that helps clarify some things. And have a great rest of your day.